Hello, and welcome to Levine Geometry 8.6, any way you slice it. Today we're going to be working on finding the area of sectors of circles and other equations for areas of circles. And I can't imagine a better way to start off than with a slide of a huge, delightfully disgusting looking pizza. There's a reason pizza slices are small, and it's because pizza slices this big look disgusting. The crust, the cheese, the sauce, all of this looks unbelievably disgusting. There is no reason that they should have done this. It is a travesty to pizza that I love. But write down 8.6 any way you slice it. I'm going to move on to the next slide. Do not write any of this down. What I'm looking for is just to tell you, you can see the pictures on the bottom, the three things we will talk about today. We're going to discover formulas and methods for calculating the area of annuluses, or annuluses, or sectors and segments of circles. Those are the three things we're going to be working on. So on the right, it's called annulus. The plural version sounds ridiculous, but it's called an annulus, and we'll talk more about that. Sector of circle and segment of circle. So the annulus of a circle is the region between two concentric circles. Remember, concentric circles are circles that share the same center point. So you can see the smaller circle and the bigger circle. The area between them that is shaded is the annulus of a circle. So please write these definitions down and draw the pictures. Sector of a circle, the region between two radii and an arc of the circle. The reason I want the picture so much and the definition is because this definition tells you what it is, but the picture really shows you. The definition, the region between two radii and an arc of a circle, a little more confusing than just looking and saying, oh, I'm looking for the area of part of that circle, and that's what the sector is. And then a segment of a circle, the region between a chord and an arc of the circle. This is a pretty easy one. You can see the chord, and the area from that to the outside of the circle between the arc and the chord is the segment of the circle. Please write these down. Pause it. I'm going to move on. Now, here we're going to talk about the annulus. Okay? How you find the area in pictures, and I just want you to draw the top picture. Just draw this top picture. But the way you find the area is you take the whole area of the outside circle. So the big R stands for the radius of the outside circle. You find that area minus the area of the inside circle with your little r, and you get the shaded region right here, which is the annulus. And that equation is pi r squared, where big R is the whole circle, the bigger circle, minus pi r squared, where little r is the radius of the little circle, and that equals the annulus. Now I want you to think about that. We're taking the whole area, everything inside of the outside circumference, everything inside of that. And then we're subtracting it from this little circle, and what's left? Well, it's the shaded region right here, and that's how you find it. So go ahead, draw this picture, write this equation. If these middle pictures help, then write that too, please. But all I need is the picture and the bottom equation. Pause it. I'm going to move on. Now we have finding the sectors of a circle. This is a big part of what we're trying to learn today. And what you do is you do a over 360 times the area of the entire circle equals the area of the sector. And the reason that works is because A stands for the degrees of the circle. A, the little a, is the degrees of the circle. So we're doing the same thing we've done to find the length of an arc. But this is the area of the sector. The degrees divided by 360 times pi r squared equals the area of the sector. So go ahead and draw this top picture again, write the equation, and you can even say, instead of A, or you can write on the side, A equals degrees. When I taught you the equation for length of the arc, I would use degrees right here. So you could write degrees over 360, if that helps you remember it. Yeah, make sure you pause that so you can write this down. Then we're going to say, well, what if we kind of combine those things? And we just want to know the area of this shaded region. We got to find the area of the whole sector. So the area of the whole sector is going to be right here. This is my sector. That's my sector. If I shade that in, I'm looking for the area of all of that, because then I can subtract the area of this triangle and I get the area of the shaded region. So that's what we're going to do. Go ahead and draw that picture. And you can see it's just, this is the picture version of what I'm saying. Get the area of the sector, subtract it from the triangle, and you get the area of the shaded region. And the way we do that is a over 360, or degrees over 360, times pi r squared. Gives you the area of the sector. That's the equation we just learned. Subtract 1/2 base times height, the area of this circle. And that equals the area of the segment. So go ahead and pause this and write this stuff down. The picture, top picture, and the equation. And if this middle part helps, then draw that as well. I'm going to move on. Now, do not write any of this down. But I want you to remind you, the length of the arc equals the degrees divided by 360 times circumference. So C equals 2 pi r. Okay? This is how we did length of arc. I know a lot of us kind of struggle with this, but this is how we did length of arc. We're taking the ratio of the arc to the entire circle. We do degrees divided by 360. The ratio of the arc over the entire circle, then multiply it by the circumference to get this little blue arc right here, part of it. We do the same thing. I'm going to go back to this slide. This is the same equation. So I want you to remember that we're just doing the same thing, but now for area. So instead of 2 pi r, that's why we do the area pi r squared. Okay? Now if you don't believe me, just watch, because I'm going to show you. Okay? If you don't believe me, just watch. So, find the area of the shaded sector, what we're just talking about. So what do? The equation is degree, or A, is what the book calls it, over 360 times the area of the entire circle. Well, the degree, you can see over here, it's 45 degrees. So we say 45 over 360 times the area. Well, area equals pi r squared, and r is 20 centimeters. R over here is 20 centimeters. So we plug in 20 right here, and we get 400 pi. Or you can multiply that out and get 1256.67 centimeters. But again, I'm sticking with my 400 pi, so I multiply by 400 pi. And again, this is going to find the area of this sector that we're looking for. So now we do 45 divided by 360, and you get 0.125 times 400 pi, and I multiply 0.125 times 400, and I get 50 pi centimeters is the area of the sector. Or I can have used 1256.67, or I can wait until the very end and then multiply 50 times pi, and you would get 157.1 centimeters. Again, this is the one I'm going to stick with because that's the way I do it, but 157.1 would also work. So hopefully, if you didn't believe me, you just watched. Now we want to find the area of the shaded segment. So here's an example of this. I do want these examples written down because there's not going to be many of them. Find the area of the shaded segment. We just learned how to do this as well. Find the area of the segment of the sector. Find the area of the sector, subtract it from this triangle, and then you have what's left over. So what I just said was find the area of the entire segment, subtract it from the area of this triangle, and you're left with this shaded region in the middle. Well, if the radius is 6 centimeters, then both of these are 6 centimeters. So now this is a problem that we can solve because first we want to find the area of the sector. It's 90 degrees. It's 90 degrees. So we do 90 divided by 360 times the area, where if the radius is 6 centimeters, we do times pi 6 squared, and we subtract it from the area of this triangle, because we're trying to get rid of this triangle from the area of the sector. Well, the area of the triangle is 1/2 base, which is 6, and height, which is 6. And there's our equation. So now we just plug and we chug. 90 divided by 360 is 0.25 times pi times 6 squared, which is 36. And you're going to subtract 1/2 of 6 times 6. So it's really 36 divided by 2, which is just 18. So we come back to this part and we do 36 times 0.25. And in this case, since this second number right here doesn't have a pi with it, we do need to get our approximate. We do need to get a number without pi in it. So 36 times 0.25 is 9 pi minus 18. And again, these will be in centimeters. So we do have to multiply the pi out. 9 times pi equals 28.27 minus 18. 28.27 minus 18 gives us 10.27 centimeters. Okay? So this is one of those problems that it takes a second to learn, but it's not as hard as it could be because it's just plugging in numbers, just plugging and chugging. And that is all the problems we're going to do today, all the notes we're going to do today. And what you can see is I can make the bad videos good for a weekend.